Okay, so we have our graph here. And remember, when we're trying to find the equation of a graph, a rational function like this, that our result is always going to end up looking like the following. It's going to be f of x equals some constant times, we're going to have factors in both the numerator and factors in the denominator, depending on the x-intercepts, depending on if there's asymptotes, things like that. So first thing we do is establish where our intercepts are and what our asymptotes are. So we have, let's see here, no intercepts. We have one intercept here at 0, 2. And we have another intercept here at 2, 0. So that's going to help us determine, this is going to help us determine the one of the factors on the top. This is going to help us determine the constant in front. And then if we label our asymptotes, we have one here at x equals -3. And we have one here at x equals +4. And it's important to note that the behavior of the graph as it approaches, this is x equals -3. Here we'll see that as it approaches from the left, it's going down. As it approaches from the right, it's going up. So they're going in opposite directions. So that means there's going to be, this factor is going to have a multiplicity of 1. Okay. And then if you notice here for x equals 4, they're both going down at x equals 4. So they're going to have a multiplicity of 2 there. Multiplicity is just the exponent associated with this particular factor. So if there's an asymptote at x equals -3, that means we're going to have a factor of x plus 3, because if I plug in -3, I'll get 0 in the denominator. If I have an asymptote of x equals 4, that means I'm going to have a factor in the denominator of x minus 4. Because if I plug in 4, I'll get 0 in the denominator, which will give me an asymptote. And since these have both ends of the graph as we approach this asymptote going in the same direction, this is going to be squared. So that takes care of my denominator. I don't need this ellipse anymore. Now the numerator is just going to be the values of x, or the factors that give me 0 at the intercepts. So I get, when x is 2, my whole function equals 0. So we know that a fraction is 0 when the numerator is 0. So if 2 gives me a value of 0 out, that means x minus 2 is going to be a factor in the top. I plug 2 in, I get 0 here, so the entire top is 0, so I get 0 for the function. So that's the only x-intercept we have, so I don't need that. So now I just have this last piece of the puzzle, which is when x is 0, y is 2. So I'm just going to substitute in 0 for x and see what I get, and that will tell me what a needs to be. So if I take f of 0, that's going to equal 2. So I get 2 equals a times, this is 0 minus 2, I'll write this out, 0 minus 2 all over 0 plus 3 times 0 minus 4 squared. So I get 2 equals, the top is going to, I'll leave the a out front. This is -2 over 3 times negative, this is going to give me -4 squared, which will give me +16. So I get, moving right along, 2 equals a times -2 over 3 times 16 is 48, which this gives me 2 equals a times -1 over 12. Oh, sorry, not 1 over 12. Let's get rid of that. 1 over 24. So if I want a by itself, I'm just going to multiply both sides by -24, -24. So this -1 over 24 and this -24 cancel. So I'm left with -48 equals a. So I'm just going to rewrite my function. I won't be able to fit it in the box, but this is going to be f of x, or y, they use y, is going to be -48 times x minus 2 over x plus 3 times x minus 4 squared. And that's it.